We're getting to the time of the year where things get frustrating because I can't just follow the same pattern every single time. I got to figure it out, and that's trig identities. We're going to use trig identities to solve stuff, but it's kind of like when you were in geometry and you had to prove that like two triangles were similar and you had to follow a whole bunch of steps to do it. We kind of do the same thing with trig identities. There's a few rules that we know are absolutely true, and that's if the sine of theta equals 1 over the cosecant of theta, just like the cosecant of theta equals 1 over the sine of theta. Same thing's true with our cosine, so our cosine of theta is going to equal 1 over the secant of theta, because the secant of theta equals 1 over the cosine of theta. Oh, I'm off the screen. My apologies. And then, of course, our tangent of theta equals 1 over our cotangent of theta. God dang it, I'm off the screen again. Right, and that's because the cotangent of theta equals 1 over the tangent of theta. So those are some rules that we're going to use every single time, that we're going to have every single time. And we're going to have a few more rules. The other ones are going to come from our Pythagorean theorem. So if you think about on your unit circle, if we make a triangle right here, remember on our unit circle our hypotenuse is 1. If we wanted to do a squared plus b squared equals c squared, we would have a squared plus b squared equals 1 squared, right? So then just a squared plus b squared equals 1, because 1 squared is 1, right? Well, if we remember, this is our cosine and this is our sine. So we can say that the sine squared of theta plus the cosine squared of theta equals 1. So we'll use that one a lot. We'll also use, I'm going to subtract over the sine. So cosine squared of theta equals 1 minus sine squared of theta. We'll use that one a lot. And then subtracting over the cosine. So sine squared of theta equals 1 minus the cosine squared of theta. So these ones are the most common ones that we're going to use, but we're going to have a couple others that we use as well. We're going to have 1 plus the tangent squared of theta equals the secant squared of theta. So we'll use that one. And then I'm going to have you guys actually write all of these down. If you want to write them down from this video, I want you to put them on a note card, because I'm going to let you guys use your identities, at least in the beginning on our tests and quizzes and stuff. So put it on a note card. We're also going to have that the tangent squared of theta equals the secant squared of theta minus 1, just because I moved the 1 over. And then we're going to have the secant squared of theta minus the tangent squared of theta equals 1. Again, because I'm moving things around from that original one. We're going to have 1 plus the cotangent squared of theta equals the cosecant squared of theta, which also means that the cotangent squared of theta is going to equal the cosecant squared of theta minus 1, and that the cosecant squared of theta minus the cotangent squared of theta equals 1. So These are all variations of the same thing. This and the one that was on the last before I erased it are variations of the same thing. And then those first three that I did were variations of the same thing. We're also gonna say that the sign, I'm off the screen. Put it right here. We're gonna say that the sign of negative theta is equal to negative sine of theta. So that'll help us sometimes. The cosine of negative theta is equal to the cosine of theta. And I can show you in class why that comes out, why both of those come out. The tangent of negative theta is equal to the negative tangent of theta. And the cosecant of negative theta is equal to the negative secant of theta. The secant of negative theta is equal to the secant of theta. And the cotangent of negative theta is equal to negative cotangent of theta. So we're gonna use this stuff in class, and we'll do some proofs and stuff like that. So I'd like you guys to have this on a note card.